This is lesson 5.5a, page 12 in your notes, and we're beginning our part of the chapter where we talk about solving quadratic equations or quadratic functions. And today specifically we're going to look at some of the algebraic ways that we do this. Before we do that though, we need to understand what it means to solve. This is our definition for to solve. It is to find the value or values of x when the function is equal to 0. So just as an example up here, you might have y equals x squared plus 2x minus 11. There's a quadratic equation. When you set that function equal to 0, so you have 0 equals x squared plus 2x minus 11, we are looking for the values of x that make this work. Now you might notice when we plug in a 0 for y, that's the same thing we do when we are solving for x-intercepts. And in fact, these values of x are the x-intercepts. That's what we're looking for when we're solving. We will call them the solutions. We're finding the x-intercepts, the things that make the equation equal 0. There's 4 main ways that we're going to focus on this. The first way is by factoring. The second is by square roots, so that we'll undo the squareds in the quadratic. The third is a new method we'll talk about later called completing the square. And then the fourth is the quadratic formula, which you've already used. Now we spent a ton of time practicing factoring because we were going to use it for this section. It's something we want to be really good at, and we're going to use it again in some other chapters. So when we say solving by factoring, like for example this one right here, we have to first make sure that the equation is set equal to 0. That's again what it means to solve. By factoring means we're going to deal with this little part here, and we'll just leave the equal 0 tacked on at the end and deal with him in a second. So we could do a guess and check or a MAC method either way. If we do a guess and check here, we know that our first term is a 3x squared, so we must have a 3x and an x, and we know that our options for the back are 7 and 1. I'm going to put the 7 here because 3 times 7 would be 21, and I know that that's close to my 20. So 3 times 7 would be 21, and then a 1. I know that I need a negative 7, so this has to be opposite signs, and I need a negative 20, so let's put negative here. So 3 times a negative 7 is negative 21. Plus 1 would give me negative 20. And plus 1 times negative 7 is negative 7. Again, MAC method, you should come out with the same answer. If you need to pause it, try your MAC and then check. We'll say equals 0. All of this is the factoring part. That's what we did last time. The new part is to say, okay, now that we know this is equal to 0, what are the values of x that would make this true? Our answers down here at the bottom should be x equals something, and there's a second x here, so we'll have x equals something. 2 answers, because we have 2 x's. So a little thought bubble with me, please, on the side. If we have 2 numbers times each other equal to 0, there's a couple of different options here. The first option is that you have some number times 0. Doesn't matter what the number is. Let's say the number is 6. 6 times 0 would be 0. Another option is that 0 times any number, again, doesn't matter what the number is. Let's just say it's 11. 0 times 11 would be 0. And our third option is that 0 times 0 would be 0. Now that's actually what we're looking at here. As you see 2 numbers here, that's what we're looking at here. We have one number, or one term, times another number, or another term. And we want to say, well, it could be that this piece, right here, this piece, this x minus 7, that might be the equal to 0 piece. In which case, doesn't matter what the first piece is equal to, but as long as our second piece was equal to 0, we'll have some number times 0, and that's how we get this equals 0 out here on the side. So, if this second piece is equal to 0, we want to solve for x. Move that 7 over, and we get x equals 7. So that's an option. Maybe x is 7. Think about what this means. Back in our original equation here, if we try plugging that in, 3 times 7 squared minus 20 times 7 minus 7, what does that equal? This would be 3 times 49, or 147, minus 140 minus 7. Sure enough, that would be 0. So this is one solution. It's a value of x that works when the equation is equal to 0. It's also possible that maybe it's not the second piece equal to 0, but maybe it's the first piece that's equal to 0. And so we're going to take this guy and say, okay, what if he, 3x plus 1, was equal to 0? What is the value of x in that case? Because we'd have 0 times something to give us 0. So we'll move over our pieces. Isolate our x, and we end up getting x is negative 1/3. Again, same thing. If we came up here and we plugged in negative 1/3, would we get a 0 out at the end? And in this case, negative 1/3 squared would be positive 1/9. So 3 over 1/9 would be 1/3. And then a negative 1/3 here, the negatives will cancel, and we'll get 20/3. And then minus, this would be minus 21/3. So sure enough, 1/3 plus 20/3 is 21/3. Minus 21/3 is a 0. This number also works. So this part was the factoring that you've seen before, and this second part down here is the solving part, which is new for us today. Let's look at a couple more examples like this. Example 2. Again, they're asking us to solve. Notice that it's not set up the way the other example was. It has to be equal to 0. So we need to move that negative 9, we need to move that 9x over. I'm going to subtract him from both sides. So this gives us x squared minus 9x plus 18 equals 0. Make a note for yourself. If it's not already 0, we must set it equal to 0. So you might have to rewrite it before you even begin your work. Again, we want to factor it and say that it's equal to 0. I'm going to use guess and check again, so x and x. It's a positive at the back, so the signs must be the same, and it's a negative in the middle, so they're both negative. Negative times a negative will be a positive. And 18. 2 and 9. 2 times 9 would be 18. 2 times 2 plus 9 would be 11. Okay, so it can't be 2 and 9. Let's do 3 and 6. 3 times 6 would be 18. Negative 3 plus negative 6. There we go. It's negative 9. All right. That's the factoring work. Now to solve it, again, we're going to say, what if this piece was equal to 0? 0 times something would equal 0. The value of x is 3. What if it was this piece that was equal to 0? The value of x is positive 6. So these are our two answers. Either x is 3 or x is 6. Those will both give us a 0 out at the end. Again, remember these are the x-intercepts we're finding. So later this week, we're going to talk about how we graph our answers and how this answer and this answer are going to show up on the graph. And we'll see those a little bit later. Don't worry about that right now, though, because that won't be in your homework yet. The second method we talked about for solving was square roots. This way is actually a little easier than the factoring way. Notice how there is no middle term. There's only the x squared. And we simply want to get x by itself. So we can move things around. We could use factoring. It'll just be a little weird because there's no middle term. So instead, square roots are when you only have an x squared term, no middle x. So we will move over that 486 on both sides. So we get 6x squared equals positive 486. Divide both sides by a 6. We get x squared equals 81. And then we will take the square root. Remember that if you take the square root, you must insert a little plus minus there. So we get x equals plus or minus the square root of 81 is 9, meaning your answers are positive 9 and negative 9. Let's do the same thing for this one here. Isolate your x, so move the 4 over. X squared equals 4. Take the square root of both sides, again, little plus minus. So we get x equals plus or minus 2, which means that x equals 2 or x equals negative 2 as our two answers. In terms of your homework tonight, you should always be getting two answers, and that's just for this chapter.